Do you like books? I mean, really, really like books? Then you're in the right place. Each week, your host, Sam Hankin, interviews the best of today's top-selling authors and the up-and-coming superstars of modern literature. This is The Avid Reader. Here is your host, Sam Hankin.
Hi, everyone, and welcome to another edition of The Avid Reader, brought to you by Wellington Square Bookshop. Today, our guest is Richard Ambron, author of The Brain and Pain, Breakthroughs in Neuroscience, published by the Columbia University Press, released earlier this year. For 40 years, Richard was the director of the Neuroscience Lab at the Vagelos College of Physicians and Surgeons at Columbia University. So who better to talk with today than someone who's intimate with how pain occurs, why it happens, actually why it has to happen, otherwise we wouldn't be having this talk today. Correct. And how we can control it when it's not necessary, how we can control it when it's not necessary for self-preservation. So in addition to its erudition, an explanation of the sources of pain and how it's essentially perceived, acted upon, and mediated by the brain, Richard discusses the forefront of the science devoted to chronic pain and its management, from opioids to meditation. It may seem a bit of a tough read at first, but as Richard says, all that is needed to navigate this book is a basic understanding of biology and an ability to take on a vocabulary that may at first seem unfamiliar. But if you know what neurons, serotonin, and ATP are, you're well on your way to being an able reader of this book. Okay, one thing, and then I'll shut up. Remember, your leg doesn't hurt, your back doesn't hurt, you don't have a pain in your neck unless you're around me too long, as Richard will soon learn. Your brain is just hanging around, keeping you alive. So with that convoluted aside, welcome, Richard, and thanks so much for joining us today.
It's always a pleasure to be here. I'm very, very honored to have been invited to talk to you, and I'm looking forward to the conversation.
Likewise. You know, as I said earlier to you, as a bookseller, I'm always interested in covers and titles, and kind of as a deductive method of diving into things. Oh, do you have the book there? Can you show the cover? I have the
No,
arc.
I don't have the book here.
Hold on, I can show it. Hold on. Okay, so that's it. Well, that's pretty good. So it's The Brain and Pain, and is in blue, pain is in red, and then it's a beautiful picture of the brain with red deep in the center of it. And oh, that's the other thing. We should give credit to the illustrator Ahmet Sinav, who.
Oh, he is terrific. I mean, to have illustrations like his, to make apparent concepts and to provide detail, it's inescapable. He's a tremendous. I've worked with Ahmet in my lectures for over 15 to 20 years. He's terrific.
Yeah. After I didn't know who he was, but after I did, I went to Google and looked him up and just looked at some of the illustrations. And yeah, he makes a difference in the book. It really does help. The charts, the illustrations, the footnotes, even your acknowledgments. Oh yeah, so what I was going to ask was, when you did the cover, and you probably vetted a couple of them or worked directly with him, why is it that pain is always red?
Because red is a warning. Red stands, I guess, for blood, which is something. So red stands for something serious. And I think that's why it was in red.
And then you have the one word in calming blue. And it really, you know, like I said, you know, covers are what people look for when they come into the store. And because the brain is so realistic looking and the cover is so striking, I think that'll help a lot.
Oh, good.
So I guess the first thing for everybody is, what is pain? We think we know what it is, but you're telling us something a little bit different.
Yeah, pain is an experience. I mean, it is not a pure just sensation. It is comprised of many different factors. And all of these factors are involved in controlling and modulating the extent to which we feel pain. The important thing is, what is the intensity of pain that eventually emerges from the brain? We have three systems that deal with that. We have a somatosensory system, and that's the system that takes the information from the site of an injury up through the spinal cord to the thalamus. And then from the thalamus, we have two other systems, and these systems have really recently just come into the fore. One is the affective system, and the affective system is going to change the intensity of pain depending on anxiety, fear, it's going to modulate pain. So it's an important system for perceiving what will ultimately will be the hurt of pain. And then there's a cognitive system. And the cognitive system is going to evaluate all this information and is going to put it into perspective of what is happening now. And ultimately, it's going to make a decision, should I pay attention to this particular sensation, in this case, pain? And attention is everything, because we cannot attend to a lot of different sensations at more than one time. For example, if I'm walking in the park, I am aware that I'm alive, and it's just a basic consciousness, and I hear a dog barking. So I'm going to look at the dog, I attend to the barking. Now a fire engine comes by with a siren. I forget about the dog, and I hear the siren. Then I step on a thumbtack, and all of a sudden I feel the pain. So there's a hierarchy. The brain makes a decision that the barking of the dog was not as salient or not as important as the siren. And when you hurt yourself, that supersedes everything else. So that basically is how we experience pain. All of these influences, your previous experience, if you had trauma when you were a child, if you went to a dentist chair and you had your tooth drilled and it hurt like mad, you're going to be afraid of that for the rest of your life. So if you go to a dentist, it's going to exacerbate pain. If you have a belief that the pain is worthwhile bearing, you're lifting weights and it's beginning to hurt, but you say, oh, if I lift a little bit more, I'm going to win that competition. You'll bear the pain. So those are factors that really can modulate the extent of pain. And then, of course, the important thing is that the brain recognizes that a painful stimulus is much more important than the barking of a dog or a siren. And the
What's
question
interesting is,
yeah, go ahead.
yeah, what's interesting is, you have this old cliche that every kid learns, the burnt child avoids the flame.
Exactly.
And like in my introduction, I'm saying, hey, the reason we're here talking is because of that very precept. Why don't you go into that a little bit? Because it's so true, but no one ever really thinks about the human race not existing if pain didn't.
Yeah, pain is tremendously informative. I mean, when you are young, you're constantly testing your environment, and you have to make decisions as what to avoid, what not to avoid. And those decisions are they are necessary for life. If you are not aware of the fact that your hand is on a stove because you're not feeling the pain, then you're just not going to survive very long as a species. It just doesn't work. You have to have information about the environment, not only visual information, hearing, but it's crucial to understand things that can harm you and things that could potentially cause you to die.
And the other interesting thing you do when you explore that is you drill down to the most primitive of creatures, and you kind of give us an idea that they all feel something like pain in the nature of the necessity of avoidance.
Yes, there is a difference between a response to a stimulus that's harmful and an awareness that that stimulus is harmful. Primitive animals will respond, and I mean by respond because, say, something touches their skin. It's a simple animal, touches the skin. It will elicit a series of reactions that will result in a withdrawal. So that is a protective response, but it's really a reflex. It is only the fact that the touch has elicited the activation of a receptor that activates a channel, that activates the communication between there and the muscle that causes the contraction. There's no awareness, it's a response. We go way beyond that. We are not only aware that there is an injury, but we have hurt, we experience the pain. So it's at a much higher level. And the question becomes is, well, where in the animal kingdom can animals appreciate the fact that they are in pain? And it has to do with first of all, they need a thalamus, and they need what they call the anterior cingulate cortex, because at the anterior cingulate cortex, as far as we know, that is the center for pain in the brain. So you have to have those two elements.
That leads to, I wouldn't normally bring this up, but you did peripherally and with a footnote about, and I'm fascinated with it, just the concept of consciousness and awareness of existence. And then you have these words that we use that are general parlance words, like pain is sharp or dull or intermittent or jagged or pulsing or throbbing. These are words that are barred from normal conversations. A dog or a cat don't have those words available, but because we're aware of our own existence in a high sense.
Right.
Isn't that interesting? Well, obviously you find it interesting.
Well, it's so interesting that I'm writing a book on it. I'm writing a book on consciousness.
Oh, great.
What consciousness is, how can we approach consciousness? And you can break consciousness down into two components. If you believe, as materialists do, that consciousness emerges from the activity of neurons and circuits in the brain, then identifying those circuits is the first step. What emerges from that, what makes us conscious of that pain, is something we have no knowledge of whatsoever. So I think David Chalmers put it in a way that he said, if we can identify the centers for sensation, that's the easy question. The hard question is, what happens after those centers are activated? But he predicted that it was going to take 100 years for us to identify those centers. And to my way of thinking, we already have. I think that the center is the anterior cingulate cortex. But
I just interviewed him on his book Reality Plus.
oh, terrific.
I know, and he and I got into a kind of an argument because, he's saying that virtual reality essentially is reality. And I was arguing, no, it's not really, because you have to get up and go to the bathroom and you have to eat and you have to sleep. But it was a fun argument, but yeah.
Yeah, go ahead.
Well, I was going to say, I love the idea that you're writing a book about consciousness, because I've interviewed like 5 people recently about it. And where I again get them angry is I say, what if we live in a solipsistic universe? And they all get mad because they already have their bailiwicks. And a solipsistic universe means they're just having an interview with either no one, or I am having an interview with no one.
Exactly. You can't deny that the activity of the brain is responsible for at least the appreciating the fact that there is consciousness. But how the consciousness itself emerges from that is what we don't know. Now, there are different levels of consciousness. I mean, I think that one of the major thinkers about this was John Locke, way back in the 1800s. He distinguished thought as one type of consciousness. You have ideas, you're conscious of an idea, and sensation is another kind of consciousness. And what my perspective on this whole thing is, if you're going to study the sensation of consciousness, then the best one to study is pain. And if we can identify where in the brain pain arises, then we can look at that circuit to see what it is that somehow comes out of that circuit that gives rise to consciousness.
Like I said in the introduction, people go, I have a pain somewhere somatically on my body, but 2 cool things. One is the pain is not at the site of the lesion, as you say. And second, which is really fascinating, is that if you touch the burnt stove, your hand moves away from the stove before you feel the pain.
That's a reflex. Exactly. Yeah, the reflex has to be faster. So when the impulse reaches the spinal cord, it immediately activates the motor neuron to withdraw. And then the information goes to the brain, and then it's processed and it says, oh, that really hurts. But yeah. I think one of the most fascinating things that it's something that's always interested me. And then when they used to do those prefrontal lobotomies back in the 1950s, they would produce patients that had asymbolia. And the one patient that really struck me is he severely burned his hand on the stove. And he looked at his hand and he said, oh my God, that's really bad, but I don't care. Now, when conceptually, this is hard to understand. You are aware that there's a severe injury, but the hurtfulness of that injury does not register. And what has happened is that the thalamus is the site at which we become aware of something. The thalamus then sends information to the affective system, the cognitive system, then we feel the hurt. So, excuse me. So the hurt is separate from an awareness. So we can say we perceive pain in the thalamus, but we hurt in the brain.
And what fascinates me is you also talk of grief as pain.
Exactly.
And I'm wondering, okay, I understand that. And then I thought, well, that's us. Animals don't feel that. But then I was thinking of elephants, when their baby dies and they mourn.
Sure.
But I don't get that. I don't get, you're explaining, like I said, ATP, you're going through the peripheral nervous system, you're having everything come out of the various vertebrae. I like the way you get really excited, like when you're talking about from the thumb to axon and dendrite, 3 feet, and then you put an exclamation, thinner than a human, and you put an exclamation point. And I'm going, he's been doing this for 40 years and he's still excited about it.
Anatomy always interests me. The human body is astounding. It really is.
Well, what about the grief thing? I'm straying from what I said.
Okay, no, psychological pain is now viewed by the psychiatric community, as well as by the DMSI, which is the Bible for them, as a legitimate form of pain. It is viewed as it can be as intense as an injury to the periphery, but it does not involve the somatic sensory at all. So this is pain that is created by activity of the brain itself, independent of what's going on outside. And where does that, if you look at a person who's in pain, who's grieving, and you do an imaging study, what lights up? The anterior cingulate gyrus, the same place that somatic pain comes, inflammatory pain, injury, all of it feeds into this system.
Yeah, but it doesn't make any sense to me as a layman, because it's like fitting a square peg in a round hole. There's no nervous system, peripheral or central, that's giving the brain the information that it needs. Go ahead.
Yeah, the visual system. And I mean, you can create an idea that is disturbing, right?
Yeah.
You don't have to have an.
I do it every day.
Okay. So why can't somebody who thinks about somebody who they've lost, why can't that activate circuits that feed into the pain pathway, independent of anything else?
What is the perception then? You talk about sensation, and then sometimes you talk about modality. Okay, it is a sensation, correct? Grief.
Yes.
But
it is perceived as pain.
Like Douglas Hofstadter said, it's kind of it's a loop. It's recursive. It's coming from inside something and it's going back to the same spot, kind of.
Well, I mean, the brain can control the brain. I mean, look at mindfulness training. People who are experienced can willfully, and I think that this is remarkable, they can willfully distract themselves from pain. If they're in pain, these practitioners can willfully say, I'm not going to acknowledge, I'm not going to attend to that sensation, I'm going to switch to something else. And it all occurs within the brain.
Well, I don't really mean to skip ahead, but since you bring up mindfulness, when you go, and we'll come back to it, but when you go to the idea of chronic pain and alternative methods of ameliorating it, you talk about mindfulness and you talk about monks, and so go into that a little bit, then we'll come back and then we'll go back to it.
Okay, there was always this anecdotal evidence that practitioners of the deepest form of mindfulness training had control of emotions and sensations. And don't forget, we go back to the attentiveness. You could attend to the dog, you attend to the siren. If you can force your brain to attend to something other than the pain, then you are really essentially distracting the brain and you are relieving the pain. It's the basic for dentists having music in their offices. Listen to the music. You can't listen to the music and be in pain at the same time. So you focus on the music and the pain disappears. So what is going on with mindfulness? Well, you can ask, well, what happens in the brain in mindfulness training? And if you look at that, it's the same similar systems in the brain are activated in mindfulness training to alleviate pain. The difference is, well, this is a little bit jumping ahead, but it does not involve the periaqueductal gray. It doesn't activate the opiate system like the placebos. So placebos relieve pain by causing the release of opiates to block the somatic sensory system. Mindfulness acts in a different way, but it has basically the same effect. So I think that mindfulness now is one very powerful way to alleviate pain by being able to shift the focus away from the pain. The problem is, and it's a major problem, it's very difficult to attain that position, that state. It takes many, many years to be able to do that. Lesser forms of mindfulness, where you focus attention on breathing, you can relieve anxiety. Well, relieving anxiety is important because people who are anxious the pain will be exacerbated. So telling a person who's in chronic pain that we're going to teach you mindfulness to alleviate the pain is not likely to work. I mean, they're just too fearful of the pain. They're just too anxious. And that's why toward the end of the book, I think that what we are faced with now is the way to control chronic pain is to find this center, hopefully it's the anterior cingulate cortex, and then use procedures like optogenetics to prevent those circuits from being activated and going and giving rise to the pain. And I think that that's where the future of pain management is going to be.
And you're right. And I didn't mean to jump ahead to the last section of the book, but I can take you back to the middle because we do talk about, you talk about this interesting concept, because there's a difference between this pain that allows you to move your hand away from the stove or put the knife down or run. And you talk about the beginning of chronic pain in the sense of the brain, and this is, I didn't understand this, the brain going awry, and you use the word awry. Right. So what, is the brain making a mistake? Is that the genesis of chronic pain?
Well, there are many different kinds of chronic pain. I mean, chronic pain is really a very wide category of pain. And what I was talking about, the pain going awry, is central pain, which is the worst kind of chronic pain. Because so the thalamus is receiving information normally from an injury in the hand or whatever, and it sends that information to these centers in the brain. But suppose the neurons that do that just become spontaneously active. Okay, what happens? They send a signal to the pain centers. Pain centers doesn't know that there's no connection to the periphery, and you have extreme pain. That is one form of chronic pain that I'm talking about. The brain goes awry because it spontaneously starts to send pain signals when there is no reason for those signals to exist. And if you look at imaging of people in there and who have that pain, it's the thalamus that's activated, it's what they call the insular cortex, and it's the anterior cingulate cortex. So those three elements are involved, but it's like phantom limb pain, right? People have pain in the hand that doesn't exist. Why? Because you're getting activity, spontaneous activity from a nerve that was normally connected to a target. The brain doesn't know what the target is. The brain only responds to a stimulus that's coming in. And that stimulus, if it's coming from the brain itself, stimulation of the thalamus, it doesn't know that the thalamus is not getting information from someplace else. That's what I meant, the brain going awry.
Do you think going awry is part of a misfiring of the evolutionary process that I think should have been selected out? Or do you think it's a part of our modern environment that has given rise to the concept of chronic pain?
Well, I think that central pain is a pathological situation. It is caused by, for example, the thrombosis in the thalamus. A blockage in some of the arteries of the thalamus will cause the neurons to start firing. That was the Lamech syndrome, which is one of the most horrendous kinds of pain that exists. The thalamus, neurons in the thalamus that presumably repress certain impulses were now released, and they just start firing and they send the pain. So it's a pathology. It's not evolutionary. It's just damage.
There are a couple of words you use that are trigger words in today's politically correct environment. One is stereotypic, because people shy away. They're thinking in terms of stereotypes, but it's not really a stereotype. Talk about how you use the word stereotypic, because it's important.
Well, stereotypic is important because otherwise physicians couldn't make any diagnoses. I mean, your nervous system, your peripheral nervous system is wired the same way mine is. You have the median nerve that goes to the same place, an ulnar nerve, a sciatic nerve, they all go to the same place. They all have the same function. And a surgeon can operate and he can find those nerves right away. If the nervous system was not stereotypic, in other words, not have common elements in everybody, then if it was random, how would we ever know what nerve is connected to what part of the body? So I use stereotypic in that sense of the word, meaning common. Yeah.
And the other word, and I'm going forward again, because of Appalachia, because of the Purdue family, because of oxycodone, this concept of opioid use as an amelioration of chronic pain is like scary now to people. We should never use it. And you're not saying it should never be used. You're saying it has a place.
Right. There is the only place that a lot of people can seek pain relief are the opiates. There's no substitute for them. The problem is that they develop a tolerance and then they lead to an addiction. So the downside for the opiates is obviously serious, but there is no alternative. There's nothing you can use, pregabalin, you can use all of these other things. They really are, they're secondary to the system. I mean, stress-induced analgesia is the most effective way to shut down pain. You know, when soldiers were grievously injured, they ignored the injuries to escape. So they did not feel pain. And the reason is, as Hans Kosterlitz and these other people did, is because it caused a release of opiates that went through a descending system and activated on the synapse between the first and second order neuron, shutting the synapse down. So now the pain could not get to the thalamus, and that's the most extreme. Well, that's what opiates are doing. They are mimicking that stress-induced analgesia.
Yeah, go ahead.
Okay, the problem is that they were overprescribed.
Right.
I mean, you know, you go to you have a hip replacement and the doctor gives you 30 pills. You may take 2 of them. And if you keep on taking them, you didn't need them, but then you have to take more, et cetera, and it builds. So if they are judiciously prescribed, the opiates are the only solution to most persistent pain.
I remember I had a gingivectomy and the doctor gave me oxycodone, and like an idiot, I cut it in half, not realizing it was time released. And that was the last time I would ever. Yeah. I was, and then in retrospect, I thought, why would he give me this? You know, why would you do this? Why would you automatically overprescribe?
Exactly. I mean, that certainly is part of the problem. Definitely.
Well, as long as we're here, I guess the alternative would be what you're talking about, not only in mindfulness but you bring in Eastern medication, Eastern medicine early on, actually, and talk about its the efficacious nature of it, which was, you know, by our peers looked at with an extreme skepticism, if not scorn.
Right, because the Western tradition was based on evidence. You had to have evidence that what you were doing actually had the result that was expected. There was no evidence, no concrete evidence to show that mindfulness or any of these other procedures actually worked, because they had no way of looking at the brain. So everything that you heard was anecdotal. It's only when we started to look at, we use brain waves to see whether the practitioners can develop more alpha waves, which means that the brain is relatively calm, gamma waves, et cetera. It's only when we started looking at these procedures and then evaluating meditation that we realized that meditation is a real phenomenon, just like a placebo is a real phenomenon. You know, people say, oh, placebo. You know, if he believes that, if he has a belief in a pill that can't cause anything, then he doesn't have any pain. But that's not true. We know that placebo is a real thing. It's based on belief.
Well, the thing is that most people, before they read the book, you know, I'm going into it. I mean, I did know I was wrong, but I mean, yeah, if I cut my finger, I'm thinking the pain is in my finger. The pain resides here. And so therefore, before you read this book, and then you think about, okay, whether it's mindfulness or acupuncture or meditation, or some other form of Eastern medicine, you're going to think why does this work? Especially in light of the peripheral nervous system, which you really, I don't mean in a negative way, you really dwell on, but dwell on so that we learn. And so my knee-jerk response, okay, this is totally bypassing the peripheral nervous system. And then I thought, well, wait a minute, am I right or not? Am I right? Is it?
You are right. You are absolutely right. I focused on the first part of the book was focused on the somatosensory system because
Right.
that's the system that all the pharmaceutical companies are investigating, where most of the drugs are developed. And I do point out that developing drugs has all kinds of problems of getting to the site of where the pain is arising. But you're absolutely correct. I think that the focus for pain now has to shift into the central nervous system, into the brain, and look at the sites from which the pain eventually emerges.
Well, let's look at it anatomically, and I guess in terms of our illustrator. The cover actually does show pain residing in terms of color, dead center in the middle of the brain. But
Right.
is that true?
Yes, that is where the anterior cingulate gyrus resides. It is a location that's practically in the middle of the brain. It's above the corpus callosum, which are the fibers that cross over. So the illustration is correct. The area that it's covered is enormous. I mean, the anterior cingulate gyrus and the neuron circuits within that are tiny. They're an infinitesimal part of that round sphere, but it is dramatic, but it's realistic.
Yeah, some of the cross sections in the illustrations is like mind-boggling. Not using the mind, but it's mind-boggling because you look at these striations and you think, how the hell are we built? How is this even possible? It's like I have the same feeling you have when you put the exclamation point in.
Yes, when you look at these things and you think about them, you think about consciousness, you think about pain, you think about hurting. It is really, you're starting to look at things in a very, very different way, to understand things at a much, much higher level than before.
Yeah, I know. And then, I'm trying to think, I always do this. I'm trying to think of ways out. Okay, why is this? And then I go to the strong anthropic principle, because if it wasn't this way, you and I, again, wouldn't be able to have this conversation. So out of the multiple, if we go into the Marvel metaverse, if we go into all this infinite number of universe, this is the universe in which over millions of years, this has been able to evolve. So this is just the fact that ice is not heavier than water and drops down to the bottom of the pond and kills everything underneath it. Just one of those things, or we're in the Goldilocks zone of the solar system. Any one of those things.
You're right. Anything that, if ice didn't float, we would not have the situation that we have on the Earth now. Absolutely.
Yes. So, okay, well, let's talk about your life. 40 years, and now it's more than 40 years. How many years is it? Hey, wait a minute. When did you first think, oh, wow, this fascinates me? How old were you?
I think I wanted to be a scientist when I was about 7 years old. I was always taking things apart. I got a microscope. I just couldn't wait to look at things. I was taking every pond water I could take a look at to see what was in there. So I was always fascinated with science. And when I became a biochemist, I began to think in terms of, well, what happens? How does something emerge from just a series of reactions? And how would a behavior, as I got more sophisticated, how does a behavior occur from just a simple series of chemical reactions? And if you look at behavior, you look at the behavior, we alluded to this before, you look at the behavior of a simple animal. You look at that animal, and a perfect animal to look at is Aplysia. I mean, Aplysia has been, Eric Kandel pioneered in the use of this sea animal. And what he found is so relevant to pain and to the appreciation of pain. That's part of the book I'm writing now. But if you look at an Aplysia, if you pinch the Aplysia, the animal scrunches up. It's defensive. Waits a couple of minutes, expands. You pinch it again, it scrunches up, but it stays scrunched up longer, and then it emerges. And if you looked at that animal, you'd say, wow, this animal is really aware of the fact that there's something out there that is pinching it and is causing this. And the answer is no. The pinch activates a receptor that activates a channel, that activates a kinase, that activates the muscle, and the animal contracts. So here is a behavior that is simply a series of chemical reactions. So I call that a response. Now we have many of the same chemical reactions on our spinal cord. The transmission between the first order and the second order neuron behaves exactly the same way. If you injure yourself, you get a response and you wait. If you injure yourself the second time, the response is greater. The synapse becomes sensitized. And that's exactly what happened in aplysia. The difference is, not only does it become sensitized, but we are aware of the sensitivity because we have a brain. So we are aware of it and we appreciate it. And that's the difference. You can look at behaviors in animals. And another example from aplysia, a great example, if you expose aplysia to shrimp, they detect it, and then you shock them. And you do trials. After a while, when you expose the aplysia to shrimp, they have a defensive withdrawal. You look at that and you say, wow, the animal is afraid of shrimp. No, it's exactly the same thing. The reactors from the shrimp are activating channels, kinases, and causing the contraction.
I just thought of a great question, but I'm kind of scared to ask it because you talked to Carrie yesterday, who was my partner, but this story is about my ex-girlfriend.
Oh.
She's going to hear it.
This doesn't stay here, so you better watch out.
So my ex-girlfriend was a disciple, a student of Eric Kandel, and that's one of the reasons why I was dating her.
Really?
But, yeah, so she was studying how short-term memory is mediated to the neocortex from the hypothalamus because, and she worked with placer cells in rats with all, and I lose track of how she did it, but she used coyote urine because like rats are really scared of coyote urine. And so it would create a long-term memory because again, it was like, I better create a long-term memory. So I remember this. So my question, the way I talk about myself so much, my question though is fear, which is the anticipation of the possibility of pain, and I'm saying that, I don't know if it's true, is fear located, the receptors, the area of the brain that perceives fear or senses fear, is that in the same area where pain is?
The pain, the fear of trauma, the memory of a traumatic event is stored in a place called the amygdala. The amygdala is the fear center in the brain. Where is the amygdala connected to? Well, it's connected to the hypothalamus, and the hypothalamus is connected to the autonomic system. So when you fear something, you grimace, your heart beats stronger, you have all of the visceral responses to the fear. But the information from the amygdala also goes to the anterior cingulate gyrus.
Well, so then is the fight or flight response?
The fight or flight is going to be the autonomic nervous system. And it's a misnomer to say fight or flight because the first response to something that's fearful is to freeze.
Huh.
Animal caught in a headlight, they freeze. That is the initial response. And then after that, the autonomic nervous system kicks in and everything else. But the pain, the anticipation of the pain is going to the affective system, from the amygdala to the affective system, to the cognitive system, and then to the anterior cingulate gyrus. And then because the anxiety level is higher, the amygdala contributes and makes the intensity of the pain more severe. Now, if you have the reward system, which is the nucleus accumbens, and you say to yourself, this will hurt, but it's worth it, the pain will be diminished. So you have the yin and the yang. The reward system reduces the pain, amygdala, traumatic experiences, and anxiety exacerbates the pain.
Here's something going back to the beginning of the book, so we're moving around, is even though you say the book is, okay, you can get this, my readers and my people that are good customers in my store, they want a book that's hard to read because easy books, it's silly to read them. But anyway, one of the concepts that's difficult to understand, which you'd bring up early, is the difference between affective and effective. Like I was talking in the beginning about deductive and inductive.
Right.
So explain that so that I can understand what that means.
Okay. Effect is something that is going to be manifest by emotion. So the effective system is the system that comes out of the hypothalamus. And that is, it's going to change the heart rate. So heart rate is an effect of activation. Sweating is an effect. Grimacing is an effect. So the nervous system effects things by working through muscles and the autonomic nervous system. Affect is a variation of a sensation. That is, it can lead to an effect, but it is something that is a piece of information that has to be worked on to result in an effect. That's about.
Well, what about if I'm looking at it somewhere in between, but it's probably not. And this is another one that's going to be important to readers and something that they have to really think on. It's the concept of action potential, because I've always thought of it in terms of kinetic energy. It's not like that.
Well, it requires an enormous amount of energy, but an action potential is really mediated by the fact that the inside of the neuron is much more negative than the outside. And you have more sodium ions, which are positive outside, and more potassium ions inside. So what you have to do then is to generate an action potential is to open channels that allow the sodium to come in. And when the sodium comes in, it changes the potential inside the cell and generates what's known as an action potential. And that activates the channels right next to it. So that is propagated down all the way along the nerve. So you have voltage-dependent sodium channels that are activated in response to activation of the terminal. The activation of the sodium channels at the terminal activates the sodium channels adjacent to that. Sodium keeps on coming in, potassium coming out, then it reaches equilibrium. And so it's really the influx of sodium and efflux of potassium that is transmitted along the nerve.
Okay, well then, the next question for someone who kind of understands that is, how is that related to pain?
The way it's related to pain is that the greater the number of action potentials, the more intense the pain. And so if you prick your finger, you will generate, say, 5 or 6 action potentials, and those action potentials will go down the peripheral process of the first order neuron. It'll go to the synapse. It will activate the second order neuron, and that will reach the thalamus. So the thalamus is now receiving 5 action potentials. That's a measure of the intensity. Now, suppose you had a severe injury. You generate 150 action potentials. They will propagate along the same pathway, but now the thalamus is receiving 150 action potentials. And what is it doing with those? It's transmitting it to the brain. So you have this influx of action potentials that is a measure of the intensity of the pain that you would expect. Okay?
Yeah.
Okay. Now, once the thalamus sends that information to the centers, to the affective centers, the number of action potentials that actually reach the site that is going to give rise to the hurt is going to be modified. It's going to be modified by fear. So the number of action potentials that will reach it because it goes through the amygdala will be enhanced. So now instead of 150, you may get 165. If it goes to the reward system, the nucleus accumbens, it's going to dampen the number of action potentials. So you're going to, the center for hurt, for pain, is going to receive, say, 135. So you can modulate what goes into what comes out of the thalamus by the affective system and by the cognitive system. And the cognitive system says, hey, we have to pay attention to this because this is really important. This is a severe injury. And that's the way it works. So an action potential is nothing more than like a current along a wire. It's only the interpretation of the intensity of the current that is the important thing for pain.
It's funny when you read a book like this, you try to create analogies, and there's 2 that I thought of. One is like when, a rocket is ready to take off and it's 10, 9, 8, 7, 6. And then at 3 seconds, they have to shut down because something hasn't tripped, but everything's ready to go. The engines have even begun to start up, and then they all has to shut down. And then I thought of a fire alarm. The fire alarm doesn't sense fire. It senses heat and smoke. But then suppose it's a false alarm. How does your body and your brain shut this down and then back off? What does that?
It doesn't. It either responds or it doesn't respond. Once you've activated the peripheral nervous system, once you've released the algogenic compounds at the terminals and the action potentials are generated, they're going to continue and they're going to go to wherever it is that they're destined to go. And there's nothing you can do. You can't stop the action potentials in midstream. You can't prevent them. The only way that you can prevent the signal from getting to the thalamus is to block that synapse between the first and second order neuron. So you shut it down there, but you cannot shut down action potentials in midstream. I mean, anesthetics do it in a sense that they prevent the signals from being transmitted, but in that sense, I guess that's correct. You can do it, but that you can't do it any other way.
I never thought of that. I assumed there was a process, but I don't. I mean, the common one, and you use this, is stubbing your toe. I mean, it's not the end of the world, but it really hurts like hell. Like if you get up in the middle of the night, take a glass of water, and you stub your toe, it's like it really hurts. Yes. I mean, if you had gout, it would be excruciating.
Exactly.
So, okay, so the intensity of pain, and you talk about this too. When you slice your finger with a knife while you're cooking, initially there's this very sharp.
Exactly.
And then it goes away, kind of, and then it begins to throb. Mm-hmm. So what's that mean? I just don't understand how all of this could develop so in such a not convoluted, but it's basically such a complicated way. Why that? Why are those three things together? Sharp, stop, throb.
Well, because the body has to be able to evaluate what the situation is. So the other analogy or the other model I use is a pinprick. If you prick your finger, you are going to damage some of the cells underneath that, and it's going to release ATP because it's one of the most abundant compounds in cells. The ATP is going to bind to a receptor. It's going to activate channels. Sodium's going to come in, et cetera. You're going to have an action potential. And as I said, maybe in response to a pinprick, you have a situation where there's 5 or 6 action potentials. They're going to go up to the thalamus and it's going to be registered, oh, I have a pinprick. That happens immediately. But then what happens is another set of neurons becomes activated. So if there's a severe injury, then now you have many, many more compounds besides ATP. You have prostaglandins, you have the immune response, you have the release of substance P. All of these are going to exacerbate it because they're going to activate more channels. You're going to have more action potentials at a higher frequency. And now the initial pain is going to be overridden by the fact that now you're going to have this massive barrage of action potentials. And then after that, you'll have a quiescent period, but the site of the injury is going to be very sensitive. And that's necessary. That's an adaptive response. That's necessary to continue to protect the response, the area that's been injured. And that happens because there's a change in the sensitivity at the synapse between the first and the second order neuron. It becomes more sensitive. It no longer requires 5 or 6 or 10 action potentials to cause pain. 1 or 2 will cause pain. And that's
going to be my next question. And it sounds like you've answered it, but I may be wrong again. Sounds like an evaluatory process that the brain is evaluating what's going on, constantly evaluating.
The brain is going to evaluate what it receives. The only thing that is happening at the synapse between the first and second order neuron is the same thing that happened in aplysia when it became sensitized to the touch or the pinch. It's the same response, and in fact, the same molecules are involved. The synapse between the first and second order neuron become as sensitive as the neuron between the sensory neuron and aplysia and the motor neuron. to the same chemical reactions, glutamate, AMPA receptors, et cetera. There's no thought involved. It is just a way of, if there's a large barrage of action potentials, the response has to be that we need to protect this area, so we're going to make that synapse more sensitive to any other signals that are coming in, so we protect the site. I mean, it's a form of adaptation. It's amazing, but it's nothing but a chemical reaction, a series of chemical reactions.
Well, all right. Well, let's get to, here, you did it. I mean, everyone has a subtitle now. David Chalmers had a subtitle. So the brain and pain, got it. But then it's breakthroughs in neuroscience. So the breakthroughs in part are what we discussed about with mindfulness and meditation and things like that. Let's go through the breakthroughs one by one, and then we can conclude.
Okay, the breakthroughs are the fact that the response to an injury is not automatically pain. Pain is modulated, and it's modulated by circuits in the brain. One circuit in particular seems to be the site at which the conscious awareness of the pain emerges. And that site appears to be, and all the evidence points to it, I have the pain matrix, I have all of the data. It appears to be the circuit in the anterior cingulate cortex. If that is the case, then it is possible to modulate the activity of that using things like optogenetics. So if you can imagine that the pain is going to emerge because the circuits, after all of the processing in the amygdala, the nucleus accumbens, all of the other circuits have fed into this, and now the circuit in the anterior cingulate gyrus is going to start to fire, and it's going to result in the perception of pain. If you stop it from firing, that perception will not occur. So that is what I mean by breakthroughs. It was the addition of the affective system, the cognitive system, the feeding into the anterior cingulate gyrus, and the focus away from the somatosensory system, which is really just a relay system. It makes us aware that something has happened. It tells us, the work by Penfield and Rasmussen, tremendous, the sensory homunculus. We know where in the body the pain is coming from. But the main thing that happens is after that. It happens after the thalamus sends the information to the central nervous system. And I don't recommend that we're going to be developing treatments. We're going to be implanting electrodes into people because they've hurt their toe or anything like that. I'm talking about it for people who are dying of cancer and they're in extreme pain, for people who are in chronic pain. I mean, this is, and I don't think it's science fiction. I mean, Elon Musk is investing hundreds of millions of dollars in implanting chips into the brain to control, circuits and things. It's just an offshoot of that, but it's much more focused.
Yeah, I recognize. Yeah, that was the thing in my mind. I was going, okay, this has nothing to do with acute pain. That was the first thing. It has nothing to do, like as you said, with stubbing your toe or cutting your finger. But so if you're talking about chronic pain, you're giving several different modalities. One, you can work on it yourself. That's one thing you can do.
Right. You can try distraction. You can learn to distract it.
Second thing, before we get into the mindfulness aspect of it, is opioids. That is a way of controlling chronic pain.
But not all chronic pain. See, it can control central pain. It can control chronic psychological pain because that happens after the information has left the somatosensory system.
Well, let's take one that's problematic and problematic to diagnose, and there's magazines devoted to it that you can read. Say, take fibromyalgia.
Right. Okay, fibromyalgia was, for many, many years, was believed not to be real, but it is real. And it's probably due to inflammation of tissues. Inflammatory pain is extremely difficult to diagnose because it does not occur in response to an injury. For example, I gave a very interesting example of how difficult inflammatory pain can be to diagnose. If a surgeon leaves a sponge on a nerve.
Yeah.
Okay, the sponge is going to attract immunocytes. It's going to release the same factors that are released at the site of an injury. But those factors are not at the periphery, they're along the nerve. but they are still going to activate receptors, result in action potentials, and it's going to be perceived as pain. And people like to say, oh, that pain is in my arm. That pain is in my finger. No, they're going to look in the finger, then they're going to look in the arm. They're not going to see anything because the inflammation is on the pathway from that place to the brain. So inflammatory pain, to dismiss pain, any kind of pain, is misguided. I mean, unless the person is malingering, pain is something that's real. And it's up to the clinicians not to say, well, it's in, they say it's in your head, which happens to be true. But, you can't just dismiss it. If a person believes that they're in pain, then you have to do something to find it and so fibromyalgia for many years was not believed to be real. And it probably is a very localized type of immune response, inflammatory response. But if it doesn't occur at a target, it's going to be very difficult to localize it unless you can follow the whole pathway.
Yeah, that was going to ask about, you kind of touched on it, is referred pain, because there's just so many times I've heard doctors talk about, it's like when you have a leak in your roof and you think it's at a certain spot, but it actually, the water has run down 20 feet.
Right. I mean, pain from the viscera is referred. It doesn't occur. You feel it in the body because the brain has no perception of the fact that it has viscera. If you look at the homunculus, the homunculus is a map of the body, but it contains an infinitesimal small part of the viscera. So if the only thing that we conceive pain from is what's in the homunculus, then we can't perceive pain from our viscera. So how does this work? Well, I think it's very complicated, but it turns out that the nerves from the viscera, and I should point out, pain from the viscera is due primarily to a distension. You can expose the viscera, you can burn them, you can do all sorts of things, no pain. But you get a stone in your kidney or in your gallbladder, you've got extreme pain, and that's a distension. It activates mechanoreceptors. So what happens is that the nerves from the viscera feed into the spinal cord, and they enter the spinal cord at the same location as the nerves from the periphery. This is the theory. I think that there are problems with it, but the way it works is the second order neuron that receives information from the hand and the one from, say, the stomach or something is going to be misinterpreted by the brain as coming from the hand as opposed to the stomach. And that's why, but fortunately there are maps. We know that if you have pain in the spleen, it's going to be referred to the shoulder. If you have pain from appendix, it's going to be in the mid region. So physicians have very accurate maps that tell you if the pain is not responding in the way that you would expect as a somatic pain, that it's probably being referred.
Okay, I'll end with this, which may be somewhat disquieting to you. I can tell you with, I think, fair certainty that every time I experience pain in my life from this point on, I will think of you.
Well, that's not that doesn't bother me. It may bother you.
Well, this has been great, Richard. I've been talking to Richard Ambron, author of The Brain and Pain, Breakthroughs in Neuroscience, which is, a wonderful book to read. Plus, it's really nice to know that you're writing a book about human consciousness, which is my favorite thing to talk about.
Oh, so maybe we'll get a chance to talk about that later.
Yeah, that's what I was going to say. So I look forward to talking to you again. Thank you so much. The book's on the front table in our bookstore, and now I know how to sell it.
Great. Thank you so much. I appreciate it.
You're welcome. Thank you.